All right, happy Tuesday. Again, this is Module 1, Lesson 12 now that we're talking about. And if we look at number 1, this is just a review. We have a binomial times a binomial. So if you remember back, we'll split up the first binomial. We'll have x times the second set of parentheses, which is x plus 4, plus 2 times x plus 4. And so again, if we work through that one, now we have to multiply or distribute those values in. So we have x times x, which should give us x to the second, or x squared. And then we have x times 4, which should give us 4x, plus 2 times x, which will give us 2x, and then 2 times 4, which will give us 8. Then again, we have x squared plus 4x and 2x is 6x plus 8. That's our final answer. Again, we couldn't combine any more like terms, and hopefully everyone has mastered the binomials times binomials. All right, similarly, we look at number 2, we have a binomial times a binomial, and now it's not just an expression, it's an equation because we have our equal sign, and then we have a trinomial on the other side that has already been distributed or is combined, and then we have to figure out what x values we can plug in that will make this equation true. So first thing we want to do is, again, if we think about order of operations, let's get rid of our parentheses first. So we can do that by distributing, cutting this in and distributing. And if we look again, this binomial x plus 2 times x plus 4 is the same as up here. So we would split it just like we did for number 1. So I'm going to skip that step and just bring down my x squared plus 6x plus 8. Again, that's what we did for number 1. The left side of the equation is the same as what we started with. And that will equal the same thing that it already equals here. So it says x squared plus 6x plus 8. Now if we look at it, after distributing, just like some of the problems we had on Monday, we have the same exact thing on both sides of our equal sign. And if we think back to what it means when we have the same exact thing on both sides of our equal sign, that means that no matter what values we plug in for x, the equation is always going to be true. So again, when we say that, it doesn't mean you write all answers or everything works. You have to write all real numbers. So x equals, again, all real numbers. And we say real numbers because fractions and decimals also work. It's not just positive numbers or negative numbers, it's also fractions or whole numbers, so all real numbers. And again, the symbol for that is this. It looks like I'm almost writing an IR. And then again, we have to put that in set notation. We're putting all of our answers in set notation. So IR, all real numbers. And then if we look at number 3, it says, what does it mean when you have the same thing on both sides of the equal sign? So take a minute. You can put it in the chat for me. You can unmute yourself. What do you think it means when you have the same thing on both sides? Just like in number 2, we had a couple on Monday that had the same thing on both sides. What does that tell you about the equation? All right. Number 4, if we move on to part 2, this will be the last one we do. There's going to be a lot of group work or individual work today. So if you look at this again, it says, consider the equation x squared plus 1 equals 7 minus x. And then it says, verify that this has the solutions of -3 and 2 by substituting those values in. All right, so it gives us 2 answers and says check and make sure that both of those answers make this equation true. So first one we will do, we're going to try our -3 first. So if we do that, -3, we're plugging in for x again. So -3 squared plus 1 equals 7 minus, and then where the x is, we'll put a -3. All right, so let's solve this now. So -3 times -3 is +9 plus 1 equals 7 minus -3. So I'm going to change that minus a negative to plus. So we have 9 plus 1 equals 7 plus 3. So that says 10 equals 10. Is that a true statement at the end? Yeah, 10 always equals 10. So I'm going to put a check mark there because it worked for -3. Now I'm just going to draw a line here. And we have to substitute 2 in as well. It asked us to substitute both in and make sure that both values worked. So 2 is the second value. So 2 squared plus 1 equals 7 minus 2. And it's positive 2, so there's no double negative in this equation. So, same thing. 2 times 2 is 4. So I have 4 plus 1 equals 7 minus 2. So 4 plus 1 is 5. 7 minus 2 is also 5. So 5 always equals 5. 10 always equals 10. That tells me that both of those worked. So both of those solutions here that it gave us in our solution set, both -3 and 2, both worked.